So yes, good evening everyone. Let's start, guys. Let's start. So first of all, I will just do one thing. Uh, Let me, you know, start the recording as well, right? And then we will start with the things that we have to go through today, right? Mhm. Recording started. So let me know, guys, once my screen is visible. Okay. Is my screen visible, everyone? Quickly, yes or no? Okay, all set, guys, everyone. Everything is set. Should we start now? Should we start? Right? Yes or no? Everyone. Right? Very good. Very good. So let's start, guys. So what we have studied till now, guys, today you have to answer me what we have studied till now. Quickly, till now. What we have studied, guys? Till now, what we have studied quickly, right? What is the last thing that we have studied? Okay, so that says basics of Python. That is completely fine. We have understood basics of Python, variables, data types. All of those things are completely fine, right? Very good. We have seen inheritance. Very good. So in OOPS, what we have seen? In OOPS, what we have seen, guys, quickly. Everyone has to answer this. In OOPS, what we have seen. So can I say we started with class object? We saw two mini project. One was completely I showed you ATM project that I showed you, right? Right. Then what we have seen, guys, quickly, everyone, right? Right. Then we saw encapsulation. Very good. So we saw encapsulation, right? Right. Then we saw inheritance. So we have completed inheritance. Do you guys remember that? In the last class, we have completed inheritance. Right. Right. We have also completed static variable. Very good. Right. Right. We have also completed static variable. Right. So have we completed polymorphism? Everyone, have we completed polymorphism? Quickly, yes or no? Have we completed polymorphism? Yes or no, guys? Quickly. Everyone has to answer this. Very good. So we also discussed polymorphism. Are you sure, guys? I have discussed polymorphism. Mhm. Right. So let me check it. I don't trust that I have discussed polymorphism. What I believe, how you guys can say this polymorphism. Mhm. That is what I oops advanced 3. So inheritance, types of inheritance. See, guys, I knew it. So I haven't discussed polymorphism. How you guys are saying? So we haven't discussed polymorphism yet, guys. Right. So we have not discussed polymorphism yet. Everyone agrees to this? Yes or no? Quickly. Right. Right. So we have not discussed polymorphism. Okay. Everyone agrees to this? Yes or no? Quickly. So polymorphism has not been discussed. We had discussed super word, right? Right. How to actually inherit the constructor of other class in the child class. We have discussed this. Everyone is on the same page? Yes or no? Now, what is the agenda of today's class? Right. What is the agenda of today's class? This is very important. Right. 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 So today we are going to start with polymorphism. Polymorphism. Then we are going to start with abstraction. Right. Right. Then we are going to start with decorators. Decorators. Right. Right. So we are going to start with decorators. Right. And if time permits, right, we are also going to discuss about namespaces. 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 Right. So this would be our agenda. So this namespaces is not actually the part of OOPS, but let's I have written it here. But after this, OOPS will be completed. Right. OOPS will be completed. Right. Is it clear, everyone? Yes or no? Right. Everyone clear? Right. 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 So that is completed method overloading and overriding and operator overloading. Okay. Is it that we have completed that? So if we guys have, no one is able to answer this. No worries. I will just figure it out. Okay. Let go. Kiran says yes, completed. Now everyone is saying completed. What are you doing, guys? So method overloading, method overriding. Okay, already it has been completed. See, polymorphism simply means an object taking many forms. Yes, we have completed already. Right. Very good. So we have already completed. Thanks, guys, for helping me out. Right. So let's start, guys. Let's start. So now I will have another notebook, and then today we are going to start with a lot of things. So polymorphism has been already completed. So here I will just cut it here. Polymorphism, I will just cut it here. So I will just write it here, something like this. So maybe I will write here polymorphism. Now, guys, if time permits, today we will start with namespaces also. Namespaces, and then we are going to start with maybe, let's say, okay, let's say we will start with file handling. File handling, right? So we can start with these concepts. So should we start, guys, now, everyone? So almost we are on the age of ending Python, right? So we have already completed a lot of things, so we will be now, we are going to done with, done with this Python. So let's start. So first of all, we will start with a concept called abstraction. So what is this concept of abstraction, right? So we will start with that. So let's start, guys. Right. So to start with abstraction, let me give you some, theoretical thing to understand, and then we'll move ahead with abstraction. So what is the meaning of abstraction? If I ask you, what is the meaning of abstraction, right? What is the meaning of abstraction, right? Right. So this is an important concept in OOPS, and abstraction means hidden, hidden, right? Right. So for example, let's say, simple example, very, very simple example. Let's say, as of now, as of now, right, you are using this laptop. Do you really care, right, what is there inside the laptop? Or do you just care about the interface? Okay, you are using, that's it. Right? What is the idea? Do you care about what is inside the laptop? Everyone, yes or no? Do you really care about the laptop? What is inside the laptop? Everyone has to answer this. Yes or no? Right? Right. So you don't care. You don't care anything about what is inside the laptop. You just want to make sure that you are using the interface of the laptop. Right? So this is the whole idea. So what is abstraction? If I have to define abstraction, right? If I have to define abstraction, so let's say here I will just write it the thing, abstraction. Abstraction. If I have to define the abstraction, then I can simply say abstraction is the concept of concept of hiding complex implementation. Hiding complex implementation. So this is the idea of abstraction. Now, 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 you must be thinking, why do we need abstraction and how to implement the abstraction? This could be the basic question that you can ask, right? Obviously, this is, everyone will be asking about this, right? Why do we actually need this? What is the necessity of this particular, concept of abstraction, right? So, example, we'll see with an example, simple example. So, let's say you were, making a ATM class. So let's say ATM class. So what you were using, right? You are using ATM screen. You are not worried about what are the methods inside the ATM screen. The methods was, if you guys remember, we had discussed what was the method: check balance, or let's say deposit, withdraw, something like that. You are not worried about that. You are just using the interface. This is the first thing. But now, let's say, what you are not worried about that, what you are not worried about ATM, right? How? What you are not worried about? What you are not worried about? Where is your information stored, or which database your information is stored? You are not worried about that. Information is stored. You are not worried about that. This is the first thing. Maybe you are not worried about, right, what are other information inside that screen, other informations inside the screen. So for example, let's say bank details, right, bank details, and so on. You are not worried about that, right? You are not worried about that, right? Right. Now now this is pretty much clear that you will find in your day-to-day life a lot of classes that you will be not worried about what is getting inside. Now let's try to understand this with an example. So for example, let's say how to write an abstract method. First of all, let's understand like this. Understand that first. So what I'm going to do, I'm going to do a simple thing. So I will just write from ABC. So this ABC. What is the meaning of this ABC? I will talk about that. So import, let's say from ABC, I will import two things. First ABC, and then I am going to import abstract method. So abstract method. So I'll first try to import. Everyone please import that. What is this? I will discuss about this. No need to worry about that. So here if you see ABC means abstract class. Right. Abstract class is a module. ABC is a module. Right. ABC is a module from which you are going to import ABC and abstract method. To understand it more, I will just copy paste. So I'll just copy this and I will show you something here. So I'll just show you here ABC abstract base classes. So if you see, this module provides the infrastructure for doing something. But here if you see ABC.abc, a helper class that ABC meta has its matchless with this class, and abstract base class can be created by simply deriving from ABC, avoiding sometimes confusing meta classes uses, for example, like this. You don't need to worry about that. You don't need to worry about that. What is the meaning of this? Because I will make you understand in just few minutes. But it is just abstract base class. That's it. What is ABC? Abstract base class. So I'll just write it here. ABC is abstract base class. This is the first understanding. Is it clear so far? There is nothing to understand so far, but is it clear? Yes or no? Right? Yes or no? Now, what is this ABC? So this ABC is used to make a abstract class. How? I will just show you. So for example, let's say we have something called class. So I'll make a class, right? Right. So let's say here class, what I can do, So let's say here class career craft. So let's say career craft. So class career craft, right? And here I will just write app, career craft app, right? career craft app. Now, here you have to first write here ABC. So ABC will become the child class. This is the first thing, right? This will become your child class. So ABC will become child class and career craft becomes your parent class. So this is just using this ABC. First thing you have to do it. Now, what I'm going to do, right? Here inside this, I will define something like, let's say, def database. See here, database, right? Info. So database info. So here database info, I will just write self, and see what I'm going to do. Print, connect to database, connect to database, connect to database. This is the first method I am writing inside this career craft app, right? See it carefully. Then again, right? What I can do, let's say again I want to have this abstract method. So I want this abstract method. So what is this abstract method? Decorators that we are going to understand today, so don't worry about that. I will come to this again. So we have already seen this static variable, right? We have discussed this static variable earlier, but let's say at the rate abstract method, right? So now I will move ahead. So this is your abstract method, right? Right. Vipin says ABC is a parent class or child class. Have I missed something? So ABC will be here parent class because you are writing here inside this, and this will be your child class. So this is the understanding. Have I told opposite? Is it right? Right. But anyway, moving ahead. So let's say yes, yes. So here this is your abstract method, and then let's say here I will define a method called security app, security of the app. And here again, so let's say here abstract method security of the app self, and here I will just write pass. Very simple thing, I have done it. So everyone, first of all, type this code because again we are going to discuss everything. So ABC is abstract base class, right? Right, right. Now in one abstract class, in one abstract class, there should be at least one abstract method. So this is the second thing. In one abstract class there should be at least one abstract method. And how to define abstract method? Simply write at the rate abstract method, and let's say whatever method name you want to put, and just write pass. First of all, I will take a pause. Everyone has done so far. I know this is little bit, out of context. You might find it, but it's very easy to understand. First of all, see, I will give you guys enough time to understand this. I will explain the use cases, so you don't need to worry about that. Right, right. So first of all, is it clear, everyone? So far, everyone has written this code, right? Right, right. Is it clear? Everyone, is it clear? Quickly. I want to hear yes from everyone. So far, you have written the code, right? Right. Very good. Very good. Very good. Nice. 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 Adeline, you have written this. I don't see Ada these days. Adeline, ask Ada to join the class. Okay. Now, very good. This is the understanding, right? Now, moving ahead. Moving ahead. Now, see here. This is your career craft app. Now this career craft can also be a mobile app, right? So can I write class career craft, let's say career craft mobile app. So here I will just write mobile, or let's say career craft mobile. Let's say mobile. So this is your career craft mobile, right? Now what I am going to do, I am going to use this careercraft app as a parent class. This is interesting, and now you will be able to understand everything crystal clear. So now here comes the thing. Now what I can go do, def mobile mob login. So mobile login. So you can just do mobile login and then self. Now self, and you can just write print login to portal. Login to portal. log into portal. Right? This is the understanding. So I'll just copy. Oh, okay, I don't need to copy paste because you guys must be typing it. But this is something we have done. So what we have done? First thing, we have created a class, career craft app, which can be both website or mobile. So let's say this is your website app, and then I am going to have another mobile app for the career craft. Right now here I have imported something from parent class, that is ABC abstract base class. Then there is a method database info, connect to the database. So whenever you initialize an app, let's say you are connected to the database, after that there is a method, because abstract class should have at least one abstract method. That's why I have written here def security app. So let's say def security app. Then again I have another class career craft mobile, which is actually again, you know, inheriting from the parent class, that is career craft app. And then here you see mobile login. So mobile login, so log into the portal. So that's the understanding. Now I will execute it. Now this is going to be, fun. This is going to be fun. So can I make an object of career craft mobile here? Everyone has to answer this. Can I make an object of career craft? Say it quickly. Can I make an object of career craft mobile here? This is very, very interesting. Why? Everyone is saying why. No, why? Everyone is saying no. Why? Actually, this example, I thought a lot. What example should I take to make you understand the importance of abstract class? Because this abstraction concept is not understood very well in while teaching or while uh, in the industry also. Many people don't understand. They know the concept of abstraction because it is not used that much. But it is not used that much, it doesn't mean that you should not understand this. Right, 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 right. So if you actually execute this, see here, here you will get an error. Can't instantiate abstract class career craft mobile without an implementation of abstract method security app. Now, understanding this error, did you got the point? What is the use of abstraction? Think it now. It's time to think it now. Did you understood now what is the importance of this particular thing? Did you guys got it? Just use your brain. This is the best example I could have think of. Think it, anyone? Okay. Okay, very good. This is not a problem of yours. So let me make you understand this. So let's say here is a senior developer. Senior developer. This is your senior developer. Now see, this is going to be fun. Now he is designing some career craft website. Career craft website. Career craft website. Now try to understand this, guys. This is very fun. This is very, very useful. Now senior developer thought, okay, class career craft, very good, career staff. There should be some method about the student details. There should be teacher details. There should be some Gusau or angry student details, some Manjulika's details, something like that. Very good, not a problem. Right, 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 right. Not a problem. Now, being a senior developer, he has to think with respect to all aspects. Now he understands that my junior developer is Boca. Junior developer is Boca. Boca simply means whoever is not Indian is foolish. Right? So let's say junior developer is foolish. Right? He understands that. Right, 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 right. Adeline, Boca means foolish. Right. Okay. So let's say he understands that junior developer is foolish. But whichever website I should make, there should be something compulsory, that is, let's say, security concern. I want to make sure that the app that I am making, anywhere, wherever I want to make, right? Wherever I want to make this app, there should be some security, because this is most important. Maybe some connection to database, some some compulsory method that should be there in order to make a very good website. First of all, is this scenario clear? Is this scenario clear so far? Is this scenario clear? Right? I will repeat it again. So let's say there is some senior developer designing a website. There can be n number of methods, but senior developer at the same time knows that junior developer is foolish. So he want to make sure that some of the things should be compulsory, like security of the application, connection to the database, right? This should be compulsory. Is it clear, everyone? Yes or no? Quickly. Is it clear? Everyone has to answer this, yes or no. Is it clear, everyone? Right. So in that case, what senior developer will do? Senior developer will do very simple thing. Just make this, or make this, both of this method as an abstract method. Abstract method means until you have a method with this name in your child class, the junior developer cannot execute anything. So it's like a reminder. It's like a reminder. It's like a reminder. Please go ahead and make this method. Make sure that this method is present in this your class, whatever you are making. Then only you can move ahead. This is the complete understanding. Many of the people, many of the tutor are just stuck to one point, that it hides the detail. But how it hides the detail, no one has any idea. So this is something that you have to do. So can I write it here? So here I will just write, this is, this will give an error. This will give an error. Give will an error. Use case of abstraction. First of all, first, hide complex implementation. Complex implementation. First thing. Second, it acts like acts a reminder, like a reminder that certain child class, certain child class should have should have some specific methods. Some specific methods. Is it clear, everyone? Yes or no? Now, what I'm going to do, so let's say here I will just write, in this case, the child class, mobile app doesn't have security method, So let's make it. So I'll just make it. So here in this case, I'm going to make it here, and then you will find no any issue. So here I will just go ahead, and now here I will just write def security app. So def security app. Now I can just print print the the mobile app has also the security. Is it clear now? So now if you just execute, it will not throw you any error. So it will not throw you any error. See, it will not throw you an error. So let's say this is your app 1, and then this is your app 1. So let's say this one. Now if you see app 1 dot, so mobile login security app. So let's say security app, and let's say what it does. See here, the mobile map app has also the security method. So this is the understanding. Yes, that method should be compulsorily in the child class, and that's how actually the abstraction is used. Is it clear now? Is it clear? Quickly. I will give you some more examples, so no need to worry about that. But is it clear, everyone? This is the use case of abstraction, right? Another example. So let's say here we can have class, another example. So I'll just put you another example quickly, guys. So this is was all about abstraction. There is nothing in abstraction. You will not find, to be very honest, a lot of use cases of abstraction. But why it has been given? So as a senior developer or as a manager, you have decided this is a blueprint. Then you will just throw this to your team. In that blueprint, few of the things should be always available. That should be put as abstract method. Simple, clear, crystal clear. Right? Right? So here let's say another example. Very easy example. Right? Another example. So let's say there's one use case more. There's one more use case, right? One more use case, and this is also going to be fun. So let's say class. So let's say this is a class career craft. Career craft. So here use case. Uh, one more use case. One more use case. It acts. It acts as guiding template. Template for other child class. How? I will just show you that also. So for example, let's say I will show you this with another example. So so that everyone is very much clear and should feel confident. So class career craft. So let's say there is a career craft. This is an institute, right? Now in this institute, you can have, you know, student details, teacher details, something like that. The student marks, right? So as a senior developer, what I will do? Abstract method. So let's say abstract method. What I can do? I can define the student details. Let's say student details. See the student details, and I will just have self, and then I will just write pass. See it carefully. Always use pass keyword here. So now, because you are not writing the logic here, always remember in abstract method you don't write the logic. So I'll just write here. I have yes, in abstract method you don't write the logic. You don't write the logic. Don't write the logic. You write the logic in the child class, right? Right. So in abstract class method class method, you don't write the logic. You write the logic, right? So always use pass. Now again, so this is def student details. Now moving ahead, so let's say again I will just copy paste this. So abstract method. So let's say here abstract method. Here you have, right, teacher details. So let's say teacher details, and then we have also something called, right, let's say teacher details, student details, maybe let's say student marks. Student marks. Can I say this, guys? So be it any batch, these are the things that is required. Everyone, yes or no? Everyone, be it any batch. So let's say this is your career craft, right? So I will now, what I will do, I will, let's say, make another class. So let's say class, right, this time class data science. So let's say here data science. I am making a batch data science from this career craft. So let's say career craft. So this is your career craft. Now this career craft is there, class data science, right? Now what I am going to do, so see it carefully, right? Here you have given a guiding principle that these three things should be compulsory. Out of these three, you don't need to put all three. You don't need to put only one. Whatever things you want to put, you can put it. That is the meaning of guiding principle. So let's say here you want to put only def student details. So let's say def student details. So you want to put this student details. So here I can just write self, write the logic, whatever you want to write. So return the student details. So the student details of data science course. Data science course. Data science course. Simple, right? Now here you can have student marks also, right? Student marks, right? Student marks, right? So let's say here the student marks. So let's say student marks. I will just put it like this. So return the student details or student marks of beta science course. Very simple. Now, similarly, let's say this is a data science batch. Someday I also start, let's say, web development batch. So what you will do? So here instead of data science, let's say you can have web dev. Simple. And now this time, let's say instead of student details, I want teacher details. So you can just put teacher details, teacher details. Simple, right? Right. So you can put teacher details. Right? Right. So now here you can just write student details. If you just write teacher details, teacher details of web dev course. So let's say web dev course. Now student marks of web dev. So see it carefully. Here you don't need to put all the methods here, right? Right. So here it was student, teacher, student marks. But here you have put student details, student marks. Teacher details, student marks. Right. So you don't need to put everything. Now just execute this and now make any object, whatever object you want. So let's say you want to make the object of data science. So let's say there is a student D1. So or S1. S1 is equals to this, and then you can just hit S1 dot tab. So you can get all these three things. So student details, student marks, and teacher details. But the unique part is if you write or execute teacher details, it will not throw you an error. That is the best part. So here I will write the comment. It acts as guiding template for other child class. But if one method, or let's say uh, any number of method should be there in the child class, or let's say at least one method, one abstract method should be should be in the child class, should be in the child class. And if it's not present, if it's not present, if it's not present, it will not throw error. It will not throw error. Is it clear? Are you able to see this? Everyone. So S1 dot, let's say student details here. Now if you see the student details of beta science course, so let's say now you can make an object of web dev course w1 is equals to web dev, so web dev, and now if you see w1 dot hit tab student marks, there will be their student marks. Now you can see the student marks of the web dev course. Is it clear, everyone? This is very interesting thing, not that much useful, but very, very interesting. Is it clear, everyone? Yes or no? Clear? Did you guys understood the use case of abstraction? Right. Can you pause for 10 seconds on previous code to understand more? Please look at it. Sajal, ask me if you have any doubt. Everyone, anyone has any doubts so far? Right. Quickly, anyone has any doubts? Should I move ahead, Sajil? Sada IM says here career craft is not abstract class. No, this is an abstract class. This is an abstract class. This is an abstract class because here you are using inside this abstract method. Okay, you want to put it like this, you can just put it like this because anyway you were using abstract method. So it is an abstract class. So that should not be any problem. Uh, Okay. Okay. I understood. I understood. So here, okay, I will just put it here. This is not your abstract method. So I'll just write it here. Here, career craft, career. I understood your point. So here, career craft has the abstract method. But, but career craft itself is not a abstract class. Abstract class, right? Otherwise, then you have to again put all the three methods inside them, right? Very valid point. So yes, got it? Yes or no, everyone? So here, at least one abstract method should be present in the child class, and if it's not, it will not throw error. Just write it here. Here, career craft. Having said that, this should be very much clear. Having said that, having said that, here career craft has abstract method, but career craft class itself is an abstract class. So this is the complete understanding. Is it fine, everyone? Should I move ahead now? Is it clear? Yes or no? Right? Clear, everyone? Quickly. So basically, if you have to now conclude whatever you have studied about the abstract method or abstract class, very simple thing, it is a guiding template. It helps you to make other child class following the same pattern. Clear? Yes or no? Should we see one more method? Right? Should we see one more method? Yes or no? Right? 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 Should we see one more method quickly? So let's say this is a very small method, right? Very small method, right? So let's say here we have class shape. So let's say this is your class shape, and now here again, what I'm going to do, I can just make an abstract method. So let's say abstract method, and let's say calculate area. This is another very good use case. So calculate area. So calculate area. So this is your calculate area, and then self pass. Right. Now, so calculate area can be of multiple things. It can be also of rectangle. It can also be of, circle. So I can just write class rectangle. So it has some abstract method. So class rectangle. So class rectangle, I can just pass it here like a shape, and then I can simply put def calculate area. Calculate area. I'll just copy this. So calculate area. So here I can just pass calculate area, and then just put it here. Calculate area. Then here put it something like this. Self, and then return. So let's say area of rectangle. Area of rectangle is length into width. Something like this. Obviously, you can take the data and so on. Then again, we can have another class. So what can be other class? So let's say class circle. Circle, and again it will inherit from shape. So inherit from the shape, and then here def, this time again calculate area. So this calculate area, I will just copy paste it again. So df calculate area, and then this time I can simply write pi r square, something whatever formula it is, 3.14 into r. Very simple. And now if you see, now what you can do, you can make an object of rectangle. So let's say rectangle. So I will just name it R1, and then you can just have R1 dot. So if you hit tab, calculate area, something like this. Area of rectangle is this. Similarly, area of circle, whatever you want to put, you can do that as well. Clear? This is another example. Obviously, this is a very small example, but this is the understanding. Hope this is very much clear to everyone. No one has doubt about anything. Is it clear, everyone? Quickly. Quickly, guys, everyone. Everyone is on the same page. Should I move ahead now? Right? 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 So this was just a small concept that we had to look after. Now again, this is going to be fun. So after this is done, we have decorators. This is again a very interesting concept that we are going to look at. So let's start with decorators. So actually this decorator is the last topic of OOPS. After this, we don't have any topic left in OOPS. So we are going to see decorators. Right, right. Yes, Praveen, that's the correct understanding. Abstract method, provide the blueprint or a structure of the method that should be there. Very good, very good. No, whatever you have written in a very concrete way, that's the correct understanding. So should I move ahead with the abstract method quickly? Right, right. Will you confirm any application where it is widely used? So yes, why not? But see, this is abstraction is something is not used. I have been repeatedly saying this. But what is the use case? So basically, whatever example that I gave you, this is your use case. This is your use case. This is a real world use case. Right? What is the use case? So let's say some senior developer is actually writing some code, right? Is actually writing some code, but somehow he has no any trust in people using that particular code, or let's say how that code will be consumed, right? So he designs or she designs a template. Okay, these methods are compulsory to be used whenever you are actually using this as a child, sorry, parent class, or whenever you are making a child class. So you have to compulsory follow this method. So for example, just see it carefully. So whenever you open an Uber app, right, whenever you open a Uber app, or let's say even whenever you open a laptop. So I don't know, in this laptop it's not, it doesn't show me, but I will just show you my cafe, right? So whenever you open a laptop, I don't know how many of you have observed, but by default it starts running. Have you observed this? Have you observed this? Your trial is over. Okay, my machine is not safe now. Trial ended 32 days. Okay, but anyway, have you observed this? Whenever you open a laptop, some sort of, this type of security app starts, you know executing itself. You don't do it explicitly, right? Everyone agrees to this quickly. Yes or no? Everyone agrees to this, right? Right, right, right. So now just think it. Someone is designing this laptop, right? Fine. Someone is designing this laptop. The developer knows that there can be a lot of methods, like opening the laptop, closing the laptop, restarting the laptop. There can be a lot of methods. But among all of these methods, what is that one method without which, let's say, laptops should not be dispatched? What do you think, guys? Obviously someone can say that opening of laptop is the most important one. So okay, there can be more than one method also that is compulsory required, but let's say among these three, security, opening, closing, what could be one thing? So many of you might agree with that security is the most important thing, because you will be having some files, you will be having some private files, you will be having your girlfriend picture, Manjulika's picture, right? And that, when it gets leaked out, then that's a problem. So as a senior developer, you have to think it, what is the compulsory thing that should be put, that should not be missed at any cost? Then what he will do, he will make a class, and he will not give this to anyone. He will not give access to this class. He will not give access. He will say, okay, this is my script, aircraft app. Please use this script to make the mobile app. That's it. Right, right, right. Now, when the developer, junior developer, or other fellow developer will start making mobile app, they will realize without this security app method, they cannot move forward. That's the use case. Simple understanding. And this is actually the use case. Yes, you can write any method, any number of methods here, any number of methods. That's why I gave you different method examples. So this can be also method. So this is a itself is a right. The class itself is not abstract class. So that's why I gave you this example. Whenever, right, class, normal class with abstract method, normal class with abstract method. You can have any number of method. You can also put login in whatever you want, right? Is application running in the background of the phone comes in abstraction? Yes, obviously, because you don't care about that. right? And giving permission in settings allows abstraction. Yes, that could also be one of the use case. You can think in that direction as well. Anyone else has any other questions? Right. Anyone else has any other question? Quickly. Right. Anyone has any other questions? Right. Very good. Ask me any questions, whatever you want to ask, guys, because we are at the age of ending this. Oops. And believe me, I have been following the attendance. So from the very first day of Oops, there were like 22, 23 participants, and now also 22, 23 participants. So there are like 125 registration. To be precise, it is 123, but I don't know why other people are not joining. Many of the people are, watches the recordings. Many of the time I have seen that. But the number of students attending the live class, if it has not been deteriorated, then that's a great achievement for me actually. Right, right. That's a very, great achievement for me actually, because all of those things. So basically, I don't know. Many of you have already understood machine learning, deep learning, Python programming. But if you ask me, for a fresher learner or someone who is starting with data science, which is the hardest concept, then I will go with OPS. This is the hardest concept for the people who is starting with. Because see, if you understand, you know uh, you know programming, then you understand statistics very well, because many of the practical implementation is based on programming. If you understand statistics very well, then you will understand, you know uh, machine learning very well. And if you understand machine learning very well, then you deep learning is going to be very easy for you. The whole point I'm trying to make, the programming, and in programming that too, oops is the basic building block. So if you have understood this, this is a very good achievement, right? That's the whole idea. So now moving ahead to the last topic, that is decorators. That is decorators. So what is decorator, right? This is again going to be very fun, and we are going to see this in lot of details, right? And if you ask me what is the important in decorator, already we have studied the static variables. Already we have studied. Apart from that, I am not saying these are not important, but we are going to study a lot of things. These are also important. But it simply means, it doesn't mean that you have to learn it. You don't need to learn it. You just need to know it. Okay, so should we start, guys? What is a decorator? Understand the use case in industry, because that is the most important thing. So will you use decorator? Whatever you have seen the decorator till here, abstract method, static variables, static method, that is all you have to use. Other than that, you don't have to use anything. But should you know? Yes, the answer to your question is yes, you have to know this. So should we start, guys, everyone? Yes or no? Have some water. Ah. So I'm in North India and there is like a lot of cold. Since last 3 4 days, I was actually not feeling well. But luckily today on the weekend when my class was there, so I got energetic and I started. One more thing, guys, I want to ask one thing, right? So basically, I have not given any single holiday till now. I have this plan to not give any weekend holiday, but I'm not sure how should I move ahead, because this is also my first time, the first batch I am taking, right, on my own, right? Because if I take some batch to at other places, right, the management is there to take care of these things. But I guess I am the management, I am the teacher, everything, I am here, right? So there is one simple question, right? So 30th December and 31st December, I don't know, at that weekend, how are we going to do? So we should be taking this class, or uh, calendar 2024, or is it that the last weekend you guys want to enjoy? I don't have any idea. So 2024. So here if you see 28, 29. So these will be the two dates, 28th and 29. Okay. So I guess this should be fine. I don't think there should be any problem here in attending the class, because what happens in US, and generally people after 25 are on holiday. That's why I thought to ask you guys. So is it fine for you guys to attend the class on 28 and 29? There should not be any problem, everyone. Okay, no issues. Everyone is on the same page? Yes, very good. I also don't have any issue. Very good. So now there is one more thing. So in 2025, I was seeing one thing. This 26th January is a national holiday, right? So here also many of the students make plan. So we'll discuss this at a later stage. But this day is actually I am thinking to plan for this, right? Thinking to plan for the class. I don't know, I'm not sure, but let's see what I can do it here. So 26th, 25th, I will obviously take the class. On 26th, I don't have any idea how to move ahead. So that is what you guys have to answer me, that okay, 26th there will be class or not. So we'll be seeing this at a later stage, right? Further, hmm, this 28th Fab. Okay. Anyway, this is all I wanted to just discuss. A small thing, not necessary. Right, right. So let's see. Okay, guys. So what is decorator? So we will start with decorator. Okay, one thing. Let's take 3 minutes of break. I'm not going anywhere. I'm not going anywhere. Already we have talked about that. I will not go anywhere. I will be just in front of you. Just have some water. You guys have some water, and then we will restart. Someone wants to speak up or what? I am seeing Jyoti after so many days. So let's start, guys. Now let's start. 3 minutes of break done. So now let's start. So what is a decorator? Right, right. So what is a decorator? So we'll start with a decorator. So if I say you decorate your home. So let's start with this. So decorate your home. Decorate your home. So let's say if you just click this decorate your home, so how it looks like. So let's say this is a room, maybe this is a room, right? Right. So let's imagine that there is nothing in the room, so that will be a simple room. After that, let's say you have this chair, you have some flower vessel, some mirror, some lights, and then room looks very good. Yes or no? Right. This is your decoration in real world. So can I write here similarly what is a decorator? Right. If I could define decorator here, I can again write here a decorator. Decorator. See here. A decorator, or let's say a decorator is a function, is a function, right? Right. Is a function, right? That, right, is a function that extend or modify. So modify. So a decorator in Python is a function. In a Python is a function that modify, that modify, modify, that modify slash extend the existing behavior of a function, function or class without modifying it, without modifying it. So for example, let's try to understand. A basic room is a room, right? There is no any, a problem with this. A basic room is actually a room, not a problem, right? Now what you want to do? You come with a sofa, you come with a flower vessel, right? So are you modifying the basic room? Are you breaking any wall? The answer to that question is no, you are not breaking the wall. But what you are doing? You are just putting some extra things in the room, right? Right, right, to make it more beautiful. Similarly, there is this decorator in Python. Right. So what does it do? A decorator is a function that modify, extend the existing behavior of function or class without modifying it. So you must be thinking here why I am using so modify. So let's remove this modify word. Simple. So in other words, if I have to write one liner, add some functionality. Add some functionality. Very simple. Right. 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 One more comment. This is very, very important. These decorators are only possible, are only possible. How many of you remember first class citizen in Python? First class citizen in Python. Do you guys remember this? First class citizen in Python, right? Right. So in Python, a first class citizen is an entity that can be assigned to a variable passed as a parameter that returned by a function or stored in a data structure. So basically this decorator is only possible because is also function function is also a first class citizen. What is the meaning of first class citizen? It simply means it can have some memory space. That's it, first class citizen. So that's the first understanding, right? Right. Now, moving ahead, there are two types of decorators. Two types of decorators. Decorators. First one is built-in decorator. Built-in decorators. Already we have seen this built-in decorators. Do you remember the static method? We have seen it. We'll see it again. The static method, abstract method, class method, all you have seen. So these are built-in method, abstract method. Then you have, this is your static method, this is abstract method. Then we have class method. So let's say class method, class method, class method. Then we also have something called, let's say this is your class method. Then we can have etc. So let's say I'll just write here etc because there are a lot of things. Let's say property also we have setter, getter, whatever you want to write. So etc. There can be a lot of different built-in decorators. This is the first. Moving ahead, moving ahead, you have also a concept of user defined decorators. So we'll start with this only first. User defined decorators. Right, right. So what is user defined decorators? Right. As a programmer, you define, right, right, how your decorator should look like. So we will start with that. We will start with that. Right, 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 right. Should we start now? Right. So here I will start with a very simple example. So let's say I am going to write an example. See it carefully. This is going to be very, very fun. So I will just write def my deco function. My deco function. So my deco function. My deco function. So I am writing a function, my deco function. Now I will just write two things. Print, then I will just write print, then I will just write print. This is going to be fun, right? Right. So now I am going to write it here, print. Inside this print, I will just write the line. Inside this print, the line executed before the main logic. Before the main logic. Let's say this is the thing, first thing. Now I will just write this is my main logic. This is my main logic. This is my main logic, and I will just put 11 plus 1, something like this. Now, this line, the line executed, the line executed after the main logic, after the main logic. So let's execute this and just call this function myDecoFunc like this. Right? See here, the line executed before the main logic, right? Right. Then we have this is my main logic 12 because 11 plus 1 is 12, and then finally the line executed after the main logic. This is the first thing. Fine, not a problem. Not a problem. Now the question is, here you have done things manually. So each time, so here I will write each time, the logic changes, logic changes, logic changes, or you write another function, another function. So can I write that each time the logic changes or you write another function, you have to write print statement again and again, write print statement again and again. Yes or no? Everyone agrees to this again and again? Quickly. Everyone agrees to this or not? Yes or no? Everyone agrees to this that let's say, right, right. Let's say if you are changing the logic, right, right, or you are changing the function, you have to rewrite it again and again. Quickly. Yes or no? Everyone agrees to this. I'm just seeing one yes. What about other people? Right, 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 right. Very good. So everyone agrees to this. Right. Now, can I have a generic method? Can I have a generic function? Can I have a generic function? Which I just need to execute this. How we are going to do? Right. So here again, I will just define def my decorator. And then see here. This is my decorator function, and here I will just pass something called func. So it can be anything. It can be anything. I will come to this. I will come to this. This can be anything. Now inside this function, we will be having some wrapper, def wrapper. What is this wrapper? This is going to be very interesting. Print, print. Here I am going to write. This is logic. This is the line executed before the logic. So I'm going to write like this. Then I will, the function that is passed here. So what is this func? I will come to this. So this func is actually called. So this is the way the function is called. And then I will just again copy this after the main logic. Sorry, yes. So after the main logic. This is going to be very interesting. I will discuss the use case as well. Very interesting use case. Right. This is the understanding. Now I will return wrapper. So return wrapper. Simple thing. So see what is everything. I'll just write here. My decorator. My decorator. See it carefully. Right. Right. My decorator is the decorator function. Decorator function. So we are talking about there are two types of decorator, built-in and user-defined. So we are starting with user-defined first. So here we are defining the decorators. So user-defined decorators, right? Simple. So my decorator is a decorator function. So let's say my decorator is a decorator function that takes function as argument. So this actually func is nothing but some main logic. This is some main logic. This is the first thing. Very simple, short, crisp, and clear. Then this is line executed before the main logic. Then main logic is called. Then line is executed after the main logic. And now let's say you are going to define some another method. So I will just execute this. So let's say def say hello. Let's just say hello. This is a simple function, and then I will just write print hello, hello, print hello. So let's say this is your main logic function, right? So whenever now you call this function, automatically this function should be executed in such a way that first this will be executed, then this particular function will be executed, then this will be executed. This is your decoration. And how to do that? You have to just write here in a very simple layman thing that my decorator. Done. Right? Done. So if you execute this, now you call this, say hello, then you will realize something like this. The line is executed before the main logic, then it comes function, then line is executed after the main logic. So how to understand this? This is going to be very interesting. So when say hello, say hello, say hello, when say hello, right? See it carefully. When say hello is called, right? It is actually calling wrapper first. It is actually calling wrapper first. Actually calling wrapper first. Wrapper first. Wrapper. Wrapper first. And in return, which calls, which recalls, which calls say hello. To make you guys understand, right? Right. I will do one thing, the best thing to understand anything in Python. So what I'm going to do, here, I will just write a simple thing, Python tutor, Python tutor. I will just copy this, all of this code here. So I'll just show you this. This is going to be very, very interesting. So let's say this is your function. So here, see it carefully, right? Right. What happens here? So let's say, this is my decorator. Very good. Now guys, see it carefully. See it carefully. Now I will call this my decorator, and here I will just call it something like this, right? Say hello, and then I will call say hello. Very interesting. Now guys, everyone ready? Right? 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 Rajkumar asked a very basic question. Func, why do we use it? Because func, this is the function. This is the function. But how the function is executed? All remember, everyone remembers that. That func is already executed if you just provide parenthesis. Right. Anyway, I will come to that. But let's say visualize the execution. So let's try to understand this execution. Right. How it executes. See guys. First of all, def my decorator, right? See it carefully. Next, right? Next. what will happen? It will come to this my decorator because there is no any call statement. No one is calling here. Only thing is happened that this is your global variable. Let's say there is my decorator, right? With a function inside this. See it carefully. Everything will be cleared, guys, quickly. Now, moving ahead, right? So it will go inside this my decorator func again inside this. So here, right? Here, I had told you this one thing that is very, very important. What I had told you, whenever you call say hello, it will call actually say hello function first. So let's see it. So here after that, it will come inside this wrapper. So this wrapper will be there. Then again moving ahead. So let's say moving ahead, it will return the wrapper. See it carefully. What we are going to do actually, right? Right. So basically first it has came to def wrapper now, right? Next line will be executed this one. But what is happening here? This particular function is again calling back. So what I can do to make you guys more understandable, this is very, very important to understand the execution, and I will make you guys understand. So no need to worry about that. So let's say what is happening here. First of all, this code you provided, very good. First, this line, it came my decorator func. Very good. My decorator func has been seen. Now, after that, inside this my decorator, let's go to my decorator. Then it came to this line. So this line is executed. The moment this line is executed, right? At the rate my decorator. The moment this line is executed, this knows that this we have a func, then we have a wrapper. This is the wrapper method. So that goes inside this particular function, that is def wrapper. Now, once it comes inside the def wrapper, it will go straight to return wrapper, because you know whenever a function is executed, first it will first it will come to the return statement. So now it will come to return statement. Now see, this is the stage where we have been here till now. So now here, if you just execute this, here return wrapper it came to. Now again moving ahead, see here return value, see here the same way that I had written the theory. Func, wrapper, return value goes to the wrapper. Simple. Then after that it goes to the say hello. So now say hello will come here. So say hello will be executed. See it. This plot is very, very interesting. Right. My decorator, fine. Say hello is fine. These are the two functions. Then func started. So here func is nothing but say hello. Wrapper is nothing but this wrapper method. Then this return value is calling wrapper. This wrapper is return calling say hello. And that's how now if you just execute this, now this will be first executed. The line executed before the main logic. So this will be first executed now. See, the line is executed before the logic, before the main logic. Then func will be called. Then see here, func will be called. See here, say hello has been called because of due to decorator. Then say hello has been called. Then again you move ahead, then print hello will be called because print hello is inside say hello. So now if you see print hello, you will find this print hello. So here you see hello, and then finally it will go again inside this and execute the line executed in the main logic, and that's how it has been executed. Is it clear? Yes or no? Obviously, it seems to be confusing, but there is no any confusion if you see this particular simple thing. How every function is being called. You just see it and rest. You will understand it in a very easy way. I will repeat it again. I will summarize it again how it is working. So first of all, this is the code here. You will start executing from here. So it will, this is a function, it will not go inside this, again it will come inside this. So my decorator, it found out that this is a my decorator, so this is a global variable. That's how you saw my decorator. Inside my decorator there is func. This func is nothing but say hello, so you have also got say hello. Very good, not a problem. After that you go inside this my decorator. So inside this, if you start executing, so it will just go to first the return statement. Return statement says this is the wrapper. So what is this wrapper? This wrapper is this particular wrapper function. So here you saw a wrapper function, something like this. This is wrapper on what? This is wrapper on say hello. So first of all, this will execute the first line of the wrapper. Then again, wrapper on what function? Func. So this will come to this say hello, and this will be executed, and again go back inside this, then this will be executed, and finally it will come outside the function. That's the whole understanding. Is it clear, everyone? Is it clear? Quickly, everyone, yes or no? See it, right? See it, whatever way you want to see it, but this is the understanding. Clear? Right? That's right. Vedic says, can we execute it by using my decorator? Yes, function inside function is possible. But in this case, let me see it. Whatever, if you guys have any doubt, something like this, you can always do it. Just execute this and check it out. Right. So can we just do it? So let's say my decorator. So let's say my decorator. You want to call this my decorator, something like this. So let's try to do this directly. What will happen? My decorator, something like this. So my decorator func. So name func is not defined. So let's say here you provide this parenthesis. So this also is not defined. So maybe you cannot do because func is there. So what I can do, provide say hello. Say hello. This will be more clear. Say hello. So if you see, yes, you can just do this. Because func inside func already we have seen in the last class as well. Right? Nested function, if you remember that. We can do that. So this is how you can just do it. But this is the understanding. Right? Right. Anyone have any question? So instead of say hello, the way you are putting, just pass this parenthesis, then it should work. Right? If you just pass say hello, it will not execute it. It will just show you the decorator. But in this way, you can also execute it. Better way is this one, obviously. This is the best way because I will show you one more use case. Then you will understand why it is better. So actually, this is you know used in. There is a very good use case about this. I will come to that. But is this right? Clear, everyone? Rajkumar says why we need to create fun inside wrapper method. Okay, very good. Fun inside this wrapper method. Okay, I will make you understand, Rajkumar. So let's say this is your function name. So there are two things. Whenever you define a function, there are two things. If you guys know this, there are two things. First is passing a function. Passing a function. Second one is calling a function. Yes or no, Rajkumar? Yes or no? First of all, yes or no? This is a passing a function. This is a calling a function. So whenever you pass a function, you just pass this by name. And you will see this in multi-threading, multi-processing. I will be the one who will be teaching you again. But this is the way you pass the function. Clear, Rajkumar? Yes or no? Clear? Right? Right. Now second is calling a function. So you have passed this function. Fine, you have passed this function. But this function should be also executed to get the main logic. Yes or no? Because you are doing something here. You are doing something here. So that's why to execute this main logic, you have to call this function using this parenthesis. So this is executing the function or calling the function. Calling the function. And that's why you have passed something like this. Is it clear now? Yes or no? Yes or no? Right, 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 right. Clear, everyone? Yes or no? Is it clear? Right, 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 right. Sajil says last doubt. Please go ahead. Don't worry about that, Sajil. Ask it. This is my class. My rules. Take whatever amount of time you want to take. Okay? Ask it. Okay? Meanwhile, you ask the question. Right. I will move ahead. Wrapper literal definition. Arre, wrapper means nothing. See, chocolate wrapper. So simple it here. Chocolate wrapper. Just see it. Chocolate wrapper. Chocolate wrapper. Have you eaten a chocolate? So what is this? This is a chocolate wrapper. So inside this is a main function. This is a helping function. That's it. Wrapper is a helping function. That's it. This is the literal meaning of wrapper. So here I will just write it so that if someone sees the note, then you guys don't get confused. So wrapper is a wrapper is a helping function. Very simple. Helping function. Clear? Right. Wally says one doubt, sir. Return wrapper is called to def wrapper function. Let me answer the understand the question. Return wrap. So one doubt, sir. Return wrapper is called to def wrapper function. Yes. So whenever you are writing return, return means you are executing this. So you will now call this wrapper function. The moment, the time you wrote return wrapper, it will be executed return wrapper. So return wrapper means you are returning something and you want to execute that, right? So if you see here, if I just put it here like this, so like this, so let's say what will happen. So this will not make a difference. So here if I will just execute this, so here return, see here the same thing is happening, right? So basically return wrapper is actually executing this wrapper. If you put this or if you don't put this, it doesn't make a difference. Because why this is happening? Why? Because this wrapper or this function is a first class variable in Python, or you can say first class member of the Python, and that's why you don't even actually write this like this. If you want to write like this, what will happen? The moment you write this, this wrapper will be executed here itself and you will get the result something like this. Even if you don't write the wrapper, it will be same thing, but this will be executed when the say hello is called. That's the only difference and nothing else. Right, right, right. Sajil says, Bhaiya, can we print that some output the line exited before the line logic without wrapper? Yes, you can do it. Why not? Just put this something like this. So let's say I will just copy this. You can put this way also. See it. See here, the line is executed before the main logic. Simple. You can put this way. So this can be also executed. Any other question, guys? Please go ahead. This is not that important, but we have made this more important. Right. So we are understanding this in very detail. Vipan says, please explain first class. Vipan, already I have discussed this. But to make you guys understand, if I say on Earth, which is the most important organism? What you will answer it? Which is the most important organism? Without that, Earth is no more Earth. So you can say human, plants, something like that, right? Yes or no, Vipan? Similarly, in Python also, there are some data types which is very, very important for Python. And whenever those data types are created, they will be assigned some memory, right? For example, whenever you write a is equals to 2, a is equals to 2. So the moment you write bin of a, here you have some memory. Why it has some memory? Because here a is the first class citizen in Python. So whenever you declare this, declare integer, it has gone to some variable. Right, right. That's the whole idea. Choti gold, don't say that, Sajil. So this is the understanding. Similarly, what happens in other programming languages, function is not the first class citizen, but here this is a first class citizen. To know that, just write bin, say hello. So whenever you write say hello, you will realize, okay, say hello. Okay, non-typographical. Okay, just leave it. So basically the function, I'm not able to do this, but anyway, the point I'm trying to make here, the say hello or any function in Python is similar to other object. So function is treated as an object which is actually having its own memory. That's it. That's the whole idea of first class citizen. The most important thing in Python is first class citizen, that is integer, float, and function is also one of them. Clear, Vipan? Yes or no? Quickly, right? Right. More details you can also see my that Python lecture. I had taught you guys, yes or no? Do you guys remember that I had taught you, or is it that I didn't have taught you? Right? I remember I had taught you. I don't remember exactly, but I had taught you guys. I don't know. But anyway, should I move ahead now? Right? Should I move ahead? Right? Right? Right. Very good. Now, what is the use case of decorator? So you have understood one example. Fine, that makes sense. But what is the use case of decorator? This is going to be very, very fun. What is the use case of decorator? So there is a lot of use case of decorator. The one most important use case of decorator is to know the execution time. To know the execution time. This is you will be seeing everywhere to know the execution time. Let's say this can be one of the use case. Second, sanity check. Sanity check. This can be also other use case. I will talk about both of the use case. First of all, you understand what is the meaning of to know the execution time. The meaning of to know the execution time is how much the program took time to execute itself. This is very basic, you understand. What is sanity check? Anyone has any idea of sanity check? Right. Anyone has any idea of sanity check? What is the meaning of sanity check? Sanity check is very simple. I will explain you, and this is very important thing. So let's say, right, right. Yes, Sajid, to some extent you are right. What is sanity check? So for example, let's say this is a data frame you guys have been given. So data frame has age, salary, right? Let's say maybe price of a house, something like this. Now let's say age is 25, salary is 38,000, right? Some price of a house, 26, 15,000, some price of a house, and so on. First of all, answer me a simple question. What is this age? Can I say this is an integer? Can I say this 26 is an integer? So can I say if all of the values are integer, then can I say this is an integer column? Int column. Everyone, yes or no? This is an int column. Not a problem. But let's say the same data is actually in this format. This is fun. So in this format 25, 26, 27, 28. So what is this, guys? What is this? Right? So this is a string column. So ideally a should be a integer column or a should be a string column. What do you think? Right, it should be integer column. So actually what can be done, so for all of these columns you can define a decorator method to check the sanity, that if it is an integer column or not, if it is an integer column or not, because this can be executed just one time and it will just check it out. So that is the understanding. Obviously this is not a specific use case of decorator, but this is the different use cases you can think of, right? This can be one of the use cases. Right, 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 right. So sanity checks, maybe let's say if there is some basic data type check. So basic data type check, basic data type check. So you can do this, you can implement. There can be multiple use cases, but use cases of decorators. Just I have written some examples. It's not that this is the only use case that you have to figure it out, but this is the understanding. Now, guys, moving ahead. First example, let's say to know the execution time, right? To know the execution time. Right. So let's say there is a module called import time. Interview important? Yes, you can just understand what is the use case of decorators. So for user defined, since it is a user defined, you can use anyway whatever you want, but you can just say that one of the use case can be to know the execution time. Fine. Let's say import time. What is a time? So time is a module. So time, you can just write time in Python. So this is a module. So if you just execute it, Python time module. So the time module in Python provides various functions for working with time, including pausing program execution and retrieving the current time. So I'm just copying, pasting it. So here, what is time? So time, I will just write it here. Maybe something like that. Is it clear first? Yes or no? Yes or no, guys? Quickly. Is it clear? Right? Right? So this is your time module. Obviously, you will not understand time module as of now. We will see slowly about this time module. Now I am going to define def time decorator. So time decorator. So time decorator. So I'll just write time decorator. So this is your time decorator. And just again, I will pass some function. So this can be anything, any function. So let's say def timer. I can just pass a timer. So let's say this is your timer function. So start is equals to time dot time. So basically what happens whenever you execute time dot time. So I'll just show you. Import time. So it will give you the current time. So import time and just write time dot time. So this you will find some time. So what is this time? This is epoch time, right? So whatever time it is, let's say 14th December 2024, 7:44 p.m. This has been converted to a number. This is called as the epoch time. So start equals to time dot time. Let's say now you will execute some func. So you will execute some func, whatever function it is. Then you have end is equals to end dot time. And dot time. Then you want to just print and minus start. And minus start. What is the execution time? So I just write it here. The execution time is end minus start. Very simple. And in the last, let's say as usual, you will return this timer. Return this timer. Now let's say there is a function, right? It is time dot time at the end statement. Okay, sorry guys. Time dot time. I have written this wrong. So time dot time. Now here, this is understanding. Let's say there is a function, any function, def func test. So this is your def func test, and then I will just execute this, right? I will execute this. Let's say some value. So print maybe 2 multiplied by or 2 to power 10. So this is the understanding. So now at the rate time decorator. You have to just execute like this. Time decorator. Now if you execute this and just call this func test, you will find that the execution time is 0.0. Why? There is a reason behind it, because this calculation is too fast. Too fast. But let's say if you increase the power, so what you can do? See here, execution time is 0.000999 some seconds like this. Now, if you increase more, let's say some more value, so you will see the difference now. So okay, exceeds the limit. The limit has been exceeded, so this is bad. So let's say okay, again the limit is been exceeded. Okay, fine, we have already discussed the exceed, but that is the understanding. This is how you, or let's say 200 multiplied by this. So the execution time is 0.0 second, because this is very low. So maybe I can just have, another zeros. Or one thing I can do it. So what I can do, time dot slip. So time dot slip. So time dot slip will sleep for, let's say, 2 seconds. So let's execute this. So func test. Now see the execution time is 2.01 second. So time dot sleep means pause the program. So sleep actually pause the program. Pause the program just to show you the use case how the execution time looks like. Right? Is it clear, everyone? Yes or no? Yes or no? Right? So much important thing. This is the most important thing, whatever we have seen. Why it is important thing? There is a reason behind this. Why it is important? Because this type of things you are going to see a lot of time in your career. you will see this lot of time in your career. So that's why this is very important, because you have to know, you need to know what is the execution time that you are looking at, or if you have written some program, what is the execution time, then you can just see it using this particular method. Right, right. Is it clear, everyone? Yes or no? Right, right, right. Very good. Now it is clear. So now let's move ahead. So this was till here. We had seen function decorator. So till here we saw function decorator. Till here, till here we saw function decorator. Function decorator. Can we have the class decorator? Can we have class decorator? Can we have a Python class as a decorator? The answer is yes. A Python class as a decorator. We can have that as well. How? So let's say here, right, class my decorator. So let's say I am making a class called my decorator. My decorator. My decorator. Now inside this, I can just have init or whatever you want. If you want init, you can have, or self func. Whatever unit you want to have, you can have, but I am taking func here. So now here I can just write self dot func is equals to func. This is the first thing. Now I am also again going to write here some other method. So def call. So def call, right, call, and here I will just write self. So def call self, right. Now here I can just write print, 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 right, print something, print something before the function, before the function, and then you can just call this function func, and then print, print something after the function, print something after the function, after the function. This is the understanding. So now let's say there is another method, maybe let's say def hello. So let's say def say hello, say hello. So this is a function, and now you have a decorator class that you want to execute. So print, and then here you can just write print hello. So how you can do? So just write at the rate my decorator. That's it. Simple, right? So now if you just execute and just write say hello, say hello, say hello, then here you will find, okay, func is not defined. Why it is so? Self dot func is equals to func. I have already put. Okay, I have not called it. Guys, I'm so sorry that I haven't called it. So this should be the problem. No, this should not be the problem. Print something before the function. Okay, what I am missing. So this is fine. This is self dot func. This is fine. Then this is call, right? Okay, I understood. This should be self dot func. So done. So now if you see, print something before the function, hello, print something after the function. So now guys, first thing, here you are seeing two things that is very important. First, here you have again passed the function and you are calling this function. Very good, not a problem. But this is a new thing that you guys are looking at. This is your call. What is this call? Right, right. So this call is again a special method similar to init. We are going to see these methods, right? We are going to see these magic methods. I will come to this, but this is again a special method. So I'll just write it here. Underscore call is a special method, right? Is a special method which is invoked, which is invoked, which is invoked when you call a decorator class instance, a decorator class instance, class instance. Right. So what is happening? So whenever you call this say hello, this object of my decorator will be made. Whenever this object of my decorator will be made, so basically the first thing that will execute is the my call after init. First init, then this call will be executed, and that's how you see print something before the function hello and print something after the function. One homework here, guys. You have to copy paste all of this code in my tutor, Python my tutor, and just again see what is the execution sequence. Please do that. You guys should be doing that. Now let's move ahead to the built-in decorators. So built-in decorators. So we will start with built-in decorators. Guys, should we take a 5 minutes break and then restart? Yes or no? Quickly, right? Right. So we will again start with this. This is again going to be fun. So we start, guys, everyone. Yes or no? Quickly. Am I not visible, everyone? Am I visible or not? Am I, guys, not visible? How come I am not visible? I am visible, yes or no? I am visible. Okay. Okay, fine, 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 fine. So should we start, guys, everyone? Again, right? Should we start? So we are going to study now built-in decorator, right? So we are going to see built-in decorator, right? Already we have seen some decorators, but we will start with slowly everything, right? Right. So let's say here, the first thing that we are going to start with is, so first of all, let's say what are the built-in decorators? Maybe let's say I will just write class method, right? Static method. Then we have property, right? Property, something like that. So we'll start with first static method, because class method already we have seen, right? Right. We already have seen the class method. So we'll start with first and then we will move ahead slowly. So let's say what I'm going to do, I will define a method, or let's say first of all static method. Let's say static method. So what is a static method? So we will start with the definition first. What is a static method? So which can be called without creating an instance of the class. An instance of the class. This is interesting. This is very interesting. So I'll just show you. So let's say you have a class. Let's say class math. Let's say we have a class math and you have a method def add. See it carefully. Self x comma y, and this will return x plus y. So let's say return x plus y. Now let's say if you want to make an object, how to make an object of this? So math, so let's say calculation 1. So let's say this is your C1. So let's say this is your C1. So here I can just write make object slash instance. Yes or no, everyone? So far so good, right? Yes or no, guys, quickly. Everyone has done till now, right? Right. Quickly, right? Only Rajkumar is doing. What about other people? Right? Right. Very good. So last line. Okay, just execute last line quickly. Should I move ahead now? Very good. So now move ahead. Let's move ahead. So you have understood about that this is a method and this is an object. Very good. Now moving ahead. Let's say this is your object C1. So C1 is this object. And now C1 dot. If you execute this add. So here you will just write 3 comma 6. So it will return you 9. Everyone, yes or no? Right? Right? Yes or no? So this is the understanding. So here I can just write, if this was a regular class, this was a regular class, this is the way you work, this is the way you work. But now what I'm going to do here is make it as a static method. So I will just write it here, at the rate static method, static method. So in case of a static method, I will make few changes. First thing, here I will not write self. I removed the self completely. Now see what I'm going to do. Here you had to first make object an instance, object or instance, then you had to add it. Yes or no? Everyone agrees to this, right? Then you have to call this method add. But now you don't need to. do anything, just do math dot add and see, pass the value 3 comma 5. So let's say here you will get 8. Here you get 8. Right, right, right. So this is your static method. Now you must be wondering, what is this static method? What has happened? Why are we doing so? I will come to this. I don't worry about that. I will discuss the use case also. When to use a static method. First of all, are you guys clear about this? What I have done? I have removed the self keyword, right? I have used only at the rate static method, and now you are going to access it directly. So here add is accessed directly with the class name. With the class name, you don't need to create an object. Create an object. And one more thing, no need of self. No need of self. This is the observation. How we will be using it, I will discuss this. So far, so good. Now, guys, what are the features of a static method? I will just write this. Features of a static method. This is going to be interesting. What are the features of a static method? Right. First thing, it eliminates the use of self. This is very, very important. Right, 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 right. So you don't need to have the use of self. First thing, clear, right, right, right. Yes or no, right? Very good. This is the first thing. Second, it reduces the memory uses. Why? Everyone, can anyone explain me this? Why it reduces the memory uses? Right? Because 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 Python is not creating any instance. Is not creating any instance. Right? Right? Yes or no? Quickly. Rajkumar, I will come to that. I will come to that. First of all, focus on this. I will come to that. Right? Sada says objects created in heap memory. Actually, Sada, in this case, object will never be created. Right? It is accessing directly from the class. Class is there, right? It will directly access this method dot add from that. Right? If you talk about the calculation, yes, the calculation is being done in heap memory. But if you are making a statement, objects creates in heap memory, no. So that statement you can just change this to the calculation is done in the heap memory. Are you getting the difference, Sada? What I am saying? Yes or no? Right, right. So that's the difference. But this is the first thing. It reduces the memory usage because Python is not creating any instance. Any instance. Instance. This is the second thing. Any instance. Okay, right? Calculation is done in heap memory. You can just write it. Third thing, it improves the code readability. It improves the code readability. Readability. It improves the code readability. Right, right, right. It improves the code readability. Why? Because there is no any self. You see here, this is a function, right? Simple function, normal function, easy, right? Now the last point, again, very important. It allows for method overriding. Overriding. What is the meaning of this? Right, 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 right. If any method is defined outside the class, outside the class, actually you are going to use this method only. So define outside the class, you are going to still you are going to use going to use the class method. What is the meaning of this? The class method. Very simple, because this is the use case. This is the understanding, and this is actually the use case. I will talk about this. So what happens, guys? Let's say, okay, very good. I have an idea to explain you. Very interesting example. So let's say I have this method add. So try to understand this. This is very interesting. So let's say add, right? This is add, right? This is a function add. And what happens in this function? Let's say in this function, so two arguments are there, x and y, and it returns x plus y. Return x plus y. So what will happen in this case? So let's say add 2 plus 3, that is your, right? So 2 plus 3, 5, right? Right? Clear everyone? Yes or no? This is the understanding. Now what I'm going to do, so let's say you are working with a list. See it carefully. So now you are working with a list, right? Right. So this is your class math. Let's say list, class math list. So now how does x plus y work in the case of list? Anyone has any idea? How does class x plus y work in the list? So let's say I will just write list ops, list ops, list ops. So let's say here there is a list 2, 3, 5, or 2, 3, 4, and you just do 5, 6, 8. So what will happen? This will actually concatenate the list. Everyone agrees to this. Now here is the catch. You have one method, let's say add. You again want to make another method with the same name, but this should be specific to list. So now if you make another method with the same name, then that will be overwritten, obviously. But if you want to write a modular coding, you want to divide everything into modules, right? So in this case, what you will do? So list operation, simply write static method def add, and here what you can do? Just pass this list something like this. So maybe list ops class, list ops class, and then what you can do? List ops dot add, and then just pass like this. Very simple. Very simple. Now, okay. So here you will get 2, 3, 4, 5, 6. Simple. So what you have done? See, now even if you again use add, again you use add. So let's say again you use add 2, 3, still it will give you 5. It means this add is different from this particular add. Right. This should be more clear if you want to see the real number add or imaginary number, complex number addition. So what could have happened? Here real number, this is x plus y. For imaginary number, real plus real, imaginary plus imaginary. Right. This could be the possibility. So the point I am trying to make is very simple. Right. It allows for method overriding. If any method is defined outside the class, still you are going to use the class method. How? So this is the way you are going to use. Is it clear, everyone? Yes or no? What is the meaning of this? I'll write the comment as well. Add, say, adds to real number, to real number, to real number. But let's say you want to add, let's say you want to add complex number to complex number. So in that case, the logic will change. So in this case, logic will change. In addition, complex number addition, logic will change. Logic will change. Let's say if you want to put, let's say if you want to put both the method, you want to put both the method, both the addition method with same name, with the same name, with the same name, then add of the recent add will override, then override, right? Then in this case you can make another class, let's say some complex another class, and put the add method there, and that will be and there, and that will be specific to particular class, specific to particular class, to that class. Very simple, understand. I will see your error, Sajid. Don't worry about that. I will see at later stage. But is it clear, everyone? Yes or no? This is one of the use case. Right? 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 Same error I got. So just write static method x and y. Simple. Add dot add. I will just talk about this error. I don't worry about that. I will talk about that error. So first focus on this. Is it clear, everyone? Yes or no? Right? Quickly. Right? Have you guys understood what is one of the advantage of this? Quickly, everyone. Yes or no? Quickly. Right. But everything has one disadvantage as well. So I will just write one disadvantage. So disadvantage of this. Disadvantage. Disadvantage is that since static method doesn't have doesn't have any access doesn't have any access to attributes means data. It doesn't have any access to the attributes or data of the class, right? It's not used at other places. Frequently it's not used frequently. Very simple. See, the whole game of this class method or oops is that you want to have a modular coding. You want to have code for specific modules and their data. But here, the static method doesn't have access to attribute because you are not using self, right? Because you are not using self. Because you are not using self. You are not using self. Now, if you are not using self, it is simple that you are not going to use it more frequently because you will not be having access to attributes. So it is not useful for day-to-day methods. Simple, right? Is it clear, everyone? Yes or no? Right, 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 right. Is it clear, everyone? Yes or no? Right, right. Everyone, very good. Now, guys, let's move ahead. Uh, Hopefully there is no any questions. Do you guys have any questions? Because we are going to see the class method. Already we have seen this class method earlier as well. So class method. So we are going to see this class method. But already we have seen this. But oh no, we have seen static variable. Yes or no, guys? Quickly, the static variable we had seen. We have not seen this class method, right? So we are going to see the class method as well. So far so good, guys. Everyone, should I move to class method quickly? Right, right. Sajil says list missing one positional argument. So can you just paste the code, Sajil? Pass to list argument. That can be the problem. Class list ops, static method, add xy. That is fine. How are you calling it? How are you calling it? Okay, just remove this plus sign with the comma. Just remove the plus sign with comma. right? Very good. Now moving ahead, guys. Moving ahead. So now we have another thing, that is your class method. Before class method also, uh, mhm, let's see property. So this is your class decorator, sorry, static decorator. So let's see here one property decorator, and then we will move to class decorator, because class decorator we need a lot of discussion. So now we are going to see decorator. So property decorator. What is property decorator? Right. So it allows, it allows methods to be accessed as, to be accessed as attribute. So method is now accessed as an attribute, right? Right. So this is the, property decorator. How you can do that? Very simple. There's no any a lot of things here. Very simple. So let's say here we have class circle. So let's say class circle, a very simple class, and here we will define a init, and then self comma radius. So this is your self comma radius, right? Self comma radius. Now this init, I will just write self dot radius is equals to radius. Self dot radius is equals to radius. Self dot radius is equals to radius. Now here inside this, we will be having def area. So let's say you want to have area. So def area, and then here in this area, we can have self, right? Now, radius is equals to, see it carefully. Radius is equals to self dot radius, radius, self dot radius, and then what I can do, return 3.14 multiplied by r, multiplied by r. This is the area, right? This is the area, guys. Yes or no? Everyone agrees to this? Right, 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 right. Yes or no? Everyone. So now here I will just call this circle, right? Call this circle. So call this object circle. Let's say 5. So this will be your C1. So let's say C1. I'm calling this like this. So this is your C1 object. Now if you see C1 dot, right? If you hit tab, this is area and there is radius. Simple. So here let's say I will just write area. So this is your method. Now if you want to call it like this, then again you have to pass some value, right? So someone is saying R is not declared. Okay, this will be radius. Sorry, radius and radius, radius, radius. So radius, because C1 dot area, bound class, self dot radius. So here I have just missed, R is not declared. So I have not declared R. 3.14 radius into radius. That is completely fine. So what I'm going to do, self dot area property decorate. Okay, fine. So this is the understanding. So C1 dot area, here you see the value is 78.5. Now again, let's say C1 dot just access as an attribute some any value. So radius, you can just see the radius, that is 5, right? So this is the understanding. Now what is the difference, guys? What is the difference between main class and the property decorator here, right? So if you just write it here as the property, so let's say here, so this is a normal class. So this is a normal class. So this is a normal class. So I'll just write, this is a normal class. This is a, this is a normal object. This is a normal object. I have not used this particular property decorator since long, but let's see here. Now what I'm going to do, at the rate property. So now let's execute this. So here C1 equals to circle 5, and now execute this. So C1 dot, and this time area. So this has been now being treated as attribute. So you have to just write property. That's it. And to be very honest, I don't even use this, right? There is no any much use case of this, but let's say this is the understanding. Is it clear, everyone? Yes or no? Right? So basically what is happening, your one of the method is actually being treated as attribute, right? Right, right. So what is the use case? So whenever, what is the use case? I will just write it here. Use case, whenever, whenever any method, whenever any method is consuming any data, consuming any data from init, then you can make the method as attribute, right, as attribute for the class. Right. See what happens whenever some method you are writing that is actually taking an external argument, then it is completely fine. Then you cannot do this at the rate property. But if you say you are only using the data from the init, so the data is already being passed while creating the object, then you can treat this as a property decorator, and then you can use this as an attribute. This is the only understanding. Is it clear, everyone? Yes or no? Quickly. Yes or no? Quickly, guys. Quickly, yes or no? Everyone, right? Anyone has any doubts so far, right? Anyone has any doubts so far? Quickly. So now, guys, let's move ahead to the last decorator that we are going to look at. That is class method, right? That is your class method, right? Right, right. So if you guys remember, right? So there was one thing, static variable. The static variable already we have discussed in the last few classes. So static variable, the static method, right? Similar to that, the static variable that is already discussed in the last few classes, which was used, which was used to count total transaction or something like that. Total total value, total value, right? Total value, total values across across the instance of the class, the instance of the class. That already we have seen, right? Now let's go ahead to class method. So this is the last thing that we are going to look at. So what is the class method? So again, this is bound to the class. First thing, bound to the class, right? Can access and modify the method and attributes, right, of all instances. See, at one point of time you had used the counter using a static variable. If you tweak something, then also you can use or get the counter using class variable, class method. How? I will just show you, but don't worry about that. So let's start from the basics. First, I will make again a class that is called as class student. Now here inside this, we are going to have init method, right? Init method, and then inside this we are having self comma name. Very simple. So say self dot name. So what is this method? So method of an instance. So this will be always executed whenever you call or whenever you make an object of a class. So self dot name is equals to name. Already you know this. Now let's say here I will just make a student, and this object is, let's say, maybe Ajay. So let's say this is your student s1 is equals to this. Now if you just see s1 dot name, you will find this is the Ajay. Very good. Not a problem. Now we are going to make a class method in this particular class. How? So I'll just go ahead and just write like this. So method of an instance, I will remove this. Now let's say here I will just write student details. def student details, def student details. And now here, see it carefully. This is very, very interesting. You have to compulsorily pass this CLS, then pass name, CLS and name, and then you can just pass return CLS of name, CLS of name. And here, this you can just write class method. So class method. So class method. Simple. So this means bound to the class. Bound to the class. Now what will happen here? Very simple. Now here you can calculate. So let's say you just go ahead and just write student dot. The moment you write student, again you will get student details. So this is your class method that you are able to access, and then pass here Ajay, something like this. So you will pass Ajay, and this will be your object one, or let's say student one, object one, and then you can see the name here, object one dot name. Simple, object one dot name. So you can get this agent. So this is the way you define class method, right? This is the way you define class method. This is the understanding. Now the same thing, right, can be used actually, right, to do one more thing, that is to count total student. I will just show you, but before that I will show you one more thing. So let's say class student, I have this. Now let's say this is self name. Here I will put here name one. See what I am going to do, and again I am putting this name one. So in this case what will happen? So let's say I made an object student, let's say student, right? I'm not bringing the object, directly accessing the class. So student dot student, let's say details. And this time I will pass a name called DJ. So this is your another student. Let's say object 2. Object 2. Now guys, in this case, what will be the name? So object 2. Will I get name or name 1? Everyone. Everyone has to answer this. Will I get name or name 1? If you hit tab, here it will be name or you will get name 1. See here, name 1 I have written here. Here I have written name 1. So will I get name or name 1 here? Quickly everyone. Hit the tab. What do you get? See, Sada, what are you getting here? Name or name 1? You will get name 1. Sorry, name, not name 1. So Sada has written name 1. So here if you see, you will get Vijay. Why it is so? Because here you will not get name 1 as attribute. Why? Why? This is the beauty of class method. This is the use case actually. Because the student details is the class method. Is the class method. Right? Simple. It is the class method, and it will, the moment you have written CLS name 1, it simply means this name 1 is a variable of class, and now this name 1 will be known as name. That's it. Right. Right. So, and this is the understanding like this. Right. So this is the understanding. One more use case. So already we have discussed this, but let's say if you want to calculate, the total students, calculate total students, then how can you calculate total students, right? So let's say again class student. So let's say class student is there, and now here total students is equals to 0, and then let's say def. Here we are going to have init, def init, and then here I can just pass self, right? Right, self common. So basically we used to make method as variable for class. Method as variable, yes, you can say that. It's not a variable. You can just say that you can access the method directly, something like this. You can say that you can name the variable as a class name. That can be told, right? So now, so let's say this is your self.name. Now what I'm going to do, self.name is equals to name. See it carefully. Now again, this has been already seen this, but let's say this is a class variable. So student dot, I will just write total students. So total students is equals to student dot total students. Student, already I have discussed this uh, a few days back. Student total students plus 1, simple. Now again I can just write it here. Let's say class method, so at the rate class method, so class method, and again def get total students, so get total students, so total students, and here I will just write cls and just put it here, return cls dot total students, total students. Done. Now if you just now see student dot total students, so just do it, student dot total students, then you will find this is 0. And as soon as you make any object, so student here, let's say you made an object Ajay, so let's say this is your as1 is equals to this. Maybe again you make another object, so let's say as2, so this is your as2. This time Ajay will now become DJ, then become this as2, and then if you just do student dot, so let's say student dot, or let's say student dot total students, so if you just execute it again, so you will not get the, no, you will get the value that is 2. And let's say if you want to see the value, so dot student dot student dot get total student, so I want to just access the method, so it is also true. So you can just also get through this class method. This is the understanding. Is it clear, everyone? Yes or no? Already we had seen, but again as a part of revision we have seen. Now this class methods has been also, so decorators, so you have seen user defined decorators and inbuilt decorators, and now we are also going to look at, this is very interesting, some other concepts. Now actually your oops is over, but let's see few other concepts also. So let's say to make external method, class method, right, to be part of the class, or external method to be part of the class. How we can do, to be part of the class, or to be part of the class, or let's say class method. Let's say there is a function to make external function. The correct way would be external function, to make external function a part of class method. How can you do that? So let's say here we have this particular class, this is your class, let's say this is your class, fine, and there is one more function, so I'll just write a function def course details. So let's say def course details, and here we have course details. Now you want to make this as a part of this particular method. The first argument pass TLF, then let's say course name, something like this, course name, and then print. You can just write the details of the courses, the details of the course is something like that, course name. Now what to do next, right? So this is a method. You want to make this function, not method, this is a function. Outside the class it is a function, inside class this is a method. You want to make this function a part of this class. How can we do that? Right, very simple. First write the class name, so student, this is the class name. Then whatever name of the method you want to put, so let's say course details, so course details, so you want to put the new method name as the course detail, and then you can just write equals to, just write class method, so this is your class method, and just pass this name course detail. Very easy. You can put any other name as well, it's not a problem, but this should be class method and this should be the name of the function that you want to use. So adding the external adding the external function as class method, right? Very simple. So now if you see here, now let's say a student. So this is the class, and now here if you hit tab, so here you can just find the course detail as well. So course detail as well, you can get it. So maybe let's say data science. So data science. So now you can just look at the details of the courses data science. That's the understanding. Rajkumar says, can you please repeat? So Rajkumar, let's say this is a class. Now I have one another method that I want to make it part of this particular class. That is a possibility. If you're writing a code, you have defined a class, but soon you realized, okay, at this stage, there should be one more method inside this class. So either you have to go and remodify the class, or you can make a method like this, course details, whatever method you have, put the first value as CLS, and then whatever argument you want to put. Then what you can do for to access this class, so this class name is student, so just write student dot course details. So this will be the method name equals to this class method, that is inbuilt function, so class method, and then just provide the function name, that is your course detail, and you are done. So now you can see, if you hit tab, now earlier it was only get total student, now you will also find course detail as a method. So this is how you can make it. Clear? Yes or no? So let's say here student. So student dot, if you hit tab, you can see course details. Everyone, is it clear? But let's say now you want to delete it. Delete this class method. Delete the class method. You can do that as well. Delete the class method. You can delete that as well. How? Simple. You can use del, and then you can just write student, the class name dot course detail. Simple. So now if you just execute student dot this, you will not find this. So the student dot course detail, you will not find. See, if you hit tab, you are not able to see it. But let's say here you can just execute it. It will throw you an error, right? Right. So CLS is the reference of this class. CLS refers to the class student, right? CLS, right? CLS is reference to the class. So it is referring that this is my class student. This is a class method, meaning this is the class method. Simple. This is a class method. Clear? Anyone has any other questions? Right. So again, there is another way to also delete. So student dot, let's say get total students. So this is your get total students. So this is your 0 you are getting. You can also delete this method by using another way, that is del attribute. So delete attribute, and then just pass the class name. So class name is student, and then get total student, get total student, get total student, something like that. So if you do like this, then again the student here, if you just write like this, you will not find get total student. So it has been deleted. So the student dot get total students, I will just copy paste this. So now if I have copied paste, you will find this as an error. Can we add external method as instance method? Sada, that is not possible because of the obvious reason. If you add any class, sorry, any method of an instance, then that will be, after that will be accessed by each of the method. Are you understanding the point? Very simple. So let's say this is the class, right? You made an object. This has method m1. Now you added this to this class. Now m1 is part of this class. Now what will happen? If you make object 2, you will make object 3. You are actually giving another object information to m1. Right. Right. So instance method only will be created the way it is created from the scratch. But if you want to create class method, then you can use the class method as it is. As it is. That's the understanding. Is it clear? Yes or no? Right? Right. So this was all about the decorators, right? Now the last topic left, which could have been discussed way back, but not discussed yet. That is your magic method. So decorators, in decorators we have seen class, static, static, property, property, decorators. What we have studied, guys? Anything remaining? No. Very good. Now the last thing is dunder plus magic magic methods. So this, okay, plus static, and then finally magic methods. This is what we are going to see in today's last topic. So guys, can we take 2-3 minutes of break? Let's take 3 minutes of break. Then we will take just 50 minutes to cover this particular thing. Okay. So we'll start, everyone. Last thing of the day. So guys, no. Uh, mhm. This is going to be very interesting, right? I don't know. Today my throat is, guys. I'm feeling. Am I seeing? Am I energetic, guys, or is it that my energy is down? Am I energetic? I'm looking energetic or something like that. No one is responding. Okay, so I believe that I'm looking energetic. Okay, so let's start. So we have danda or magic or special method. So as this is something already we have discussed to some extent. If you remember constructor, right? Already we have seen that, right? We have seen that constructor. Here this is optional. You don't need to memorize, right? So basically you will see all the YouTube tutorials. They will not teach these things, right? They will not even teach this class method, static method. They will just end it at inheritance and done. But let's try to understand this. So what is this special method or magic method? So have you ever thought, guys, the moment you write 4 plus 3, what is happening at the back end? Or the moment you write uh, career plus craft, career plus craft, what is happening? Craft, right? What is happening? So here if you see career, craft, right? So basically at the back end, right? At the back end, you have some method. So let's say here I will just write a equals to 2 and b is equals to 3. So let's say this is a plus b, this is your 5, right? A plus b, right? This is your 5, right? So whenever you call this plus actually is something like this: a dot add underscore underscore again b. So this is actually happening. So this and this is actually giving the same result. But now how to know that what are the methods associated with this particular integer class? So I have been saying this, that everything in Python is an object, and this is again one proof that this is a method, right? And these are the object of the class integer. So how can you look at this? So directory of integer, the moment you do, you will find that these are the methods which are associated with the integer class. That's the idea. You can also see with respect to string, directory of string. See here, this also you are looking at. Add. Yes or no, guys? Quickly. Yes or no? Right? Right. So what are these? So these underscore underscore some method name underscore is called as dunder method or special method or magic method. Why this is called as so? So first of all, a special method or magic method. Why? Right. I will talk about that. And why it is dunder, I will talk about that as. So dunder, because double underscore is there. So that's why it is called as dunder. Why special or magic method? Because you cannot actually change this method. No, you cannot change this method. It is predefined. So double underscore, double underscore. That's why dunder method, dunder method. So D stands for double, U stands for underscore, dunder method. So D meaning double, 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 and under means underscore. That's the whole idea. Why magic method and special method? Magic slash special, because it is predefined. Predefined. So that's the understanding. Right? Now, init. Constructor is again one of the special method or magic method in it. So self, and then I will just write print. Again, this is the first thing that will be executed, that will be executed once you make instance slash object of the class. That's the understanding. So let's say here the student is there, right? Just make an object, right? So make an object like this, the student. The first thing that will be executed is this init. This is the first thing that will be executed, right? Now again, there's one more method that is again more interesting. So let's say here I will just make another method that is def underscore new self. So this is even executed. This is executed even before init. This is executed even before init. Even before init. So let's say the student, this. So here if you see, this is executed even before init. Right? So now, do you need to remember this? The answer is no. You don't need to remember any. Again, let's move ahead. Right. Let's say again we are going to see few more things. So let's say here we have another method. Let's say we will going to see another magic method def underscore str. So self. Right. So what does this do? Right. This print. This overrides. Right. This method overrides the print statement print statement of the object method of print statement of object. Simple. So what is the meaning of this? So let's say here student. So this is an object. Now earlier when you used to do this, so let's say here I will just make like this. So class student. So let's say class student, and let's say here I will just write init method, right? Init method, right? Now let's say if you print this object, so student, if you print this object, you will get some hexadecimal number that is your memory location. So let's say print, and if you just execute this, something like this. So here, this is the first thing, and this is your memory location, something like that, right? But now let's say you want to override this. So here I will just self dot phone is equals to some, or let's say here pass. I will not write something like this, pass, right? So this print object will give you some value. This is your memory location. But now if you print, right? So now if you print, right, when you have str inside this, then you will find, okay, I have not executed this. So now if you see, this is the first thing that you will be executed when you make this method override the print statement. So what I am going to do, I'm going to do this, right? And then I will just write init with pass. I don't want anything to be printed first. Anything to be printed first before init. So now if you execute, it's a return this state. So return. So now if you execute, what will happen, guys? See, this method is overriding the print statement. Overrides the print statement. Earlier, what used to happen? Right. Earlier, it was this something like this. It used to give the memory location, but now this method overrides the print statement. Is it clear? Yes or no? Right. Similarly, we have other methods as well. One last magic method that we are going to see, rep. So representation, rep. So what is happening? So let's say here class. I'll just take this example, my class, and here let's say def underscore init. and then we have self and x, self comma x, and now this is self comma x, self dot x is equals to x, right? And then what I'm going to do, so let's say here I'll just write def underscore underscore rep and then underscore self. So this is the thing, and then I will just write return my class. So f something like this, my class, class, and then I can just print like this, self dot x, self dot x. So what it will do, let's see it. So here I will just write my class 2. So my class some value, let's say here 2, and this is your object. So object is equals to like this. So this is your object. Now if I print, print, right, print here the wrapper of object, right, object, then it will give you the literal value of this. So basically, whatever you want to put here and you want to print this, you can just use wrapped. That's the understanding. Return the string representation of the object. Nothing else. Returns the string representation of object. This is another special method. Now, there is another one more special method. That is the last method that we are going to look at. So whenever you write 2 equals to 2, so it will give you true, right? Right. It will give you 2 is equals to 2. Uh, Rajkumar is asking something. I will come to that. So that is a main program. So basically what happens whenever you write this main method, right, this main method, right, it simply means this particular program will be executed, right, and you will be seeing this again when I will be working with the VS code. In Jupyter notebook it doesn't make sense to show you guys this, but this is the main program. This is a special method which revokes, right, right, revokes the main program. That's the understanding, right? Right. So you don't need to worry about that, right, as of now. Okay. So let's say here, you write true is equals to true. So whenever you write something like this, right, so what it will give you? True. So what is this? Equality operator, right? So you can have also another method that is underscore equality underscore. So let's say for that, this is the example. So class point, I'll just take it. So def init, init, yes Sada, you are right. So init, then I can just have self x comma y, whatever example you want to put, you can just put another example as well, x, and then self dot y is equals to y, and then def underscore underscore equality, so underscore underscore equality, and then self dot other, so self comma other, and then after that you can just write return, 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 return self dot x is equals to equals to other dot x, and self dot y is equals to other dot y. So what you have done here, so you actually have made another equality class which the actually compares the 2 points, right, which compares the 2 point. So for example, let's say point, this is class, let's say maybe this value is, let's say 1 comma 1, and then, or let's say 1 comma 2. So this is your p1 is equals to this, and then we have p2. So let's say p2. So here I will just put p2, and this time point is, let's say some value, other value 3. Now in this case, if I want to print it, print p1 is equals to p2, then it will give you false. So that is the understanding. So that would be all for oops, right? Nothing else. Now if I have to write the interview questions for today's lecture, right, I will write in the here itself in the notebook only, so that everything is at one place. So interview question for today's class, interview questions, right, interview questions today. First thing, what is the practical use of abstraction? No one understands this. If I have to reject someone, I will reject based on this abstraction. Then what is proper? What is decorator? Decorator. Then we have what is class method, static method, static method, and so on. What is dunder method? Dunder method, magic method, or let's say explain this. Right, right. So these are some important questions with respect to interview perspective. One more thing, right? Can I delete? Can I delete? Delete or make a method as a class method from outside? This is very, very important. This can also be asked in the interview. That would be all questions for today's lecture. We have completed OOPS. If you guys have understood till now, congratulations, you have done a very good job. Anyone has any questions to ask, please go ahead and ask. If you guys have any suggestions, any feedback in understanding anything, please go ahead and ask everyone.